Hey everybody, welcome back to the shop. It's June 26th, 2020. I'm way backed up on editing, so I don't expect this to probably air until end of July. But what this is going to be is another flea market finds vintage electronics buy. It's just like 4 items. I'm going to go through them real quick. If you're not into the vintage electronics stuff, this video might not be for you, but it's got some kind of neat finds that I was able to get. This actually came out of a shop that I picked some machinist tools from previously, and I did also get some vintage electronics out of that shop. So the situation was I went back there on the hunt for some machinist tools. Unfortunately, didn't really get any machinist tools. Ended up coming back though with some of these vintage electronics. So I ended up doing some horse trading and getting these for basically trading some machinist tools that they needed for this stuff that they had no interest in. I think I did get one machinist item. If I can dig it up, I'll add it to this pick. Alright, so let's dive right in. So the first item is this little bench power supply. This is a high elect. High spelled H-Y and then E-L-E-C. Very Korean sounding or import sounding. Probably is a cheap import. This is a model HY 1803D. I've got it plugged in right now. Appears to be working upon first look here. Of course, 0 amps because we don't have a load drawing any current on it yet. And right now it's 7.3 volts. Oh, well, hold on. This might be a little bit better quality than I thought. I'm basing that on the fact that I'm hearing actually some switching going on as I increase voltage. Almost as if like it's changing to a different regulation mode. So it seems like if we go below 9 volts, we get one mode, and then as soon as it hits 9 volts, there's that click. And it goes up to 18.9 volts. So just for giggles, let's see what my little cheapo meter here says. This is a Pocket Pro Sperry DM2A, and I gotta tell you, for a little cheap pocket meter, this thing actually has been really handy. It's got a problem with a couple of the segments of the LCD don't work, but I've been able to work around that. But I actually like this meter, oddly enough. Yeah, it's looking pretty good. Yeah, it's right on the verge of 18.99 to 19 volts, just switching back and forth, just barely. So I would say we have a good power supply at first glance. I'm not sure how it's going to act under load. I also do not know how well it regulates, and I don't know if there's any AC ripple on the. I'd have to hook the scope up, and I'm not going to bother doing that right now. But for the time being, we're just going to go with saying that, okay, it looks like we've got a good little power supply. I like the compact size of this thing, as opposed to the next power supply that I picked that I'm going to show you. Oh, this thing is a beast. I mean, get a load of this thing in comparison to the one we just took off the bench. And it's heavy. This thing screams laboratory grade power supply. Notice it's got a sticker on it, removed from service, do not use. Looks like that was done in 2017. Technician's name is on here. But what this is a Hewlett-Packard laboratory grade power supply. Now this is exactly how I found it. Actually it was almost even more apart than this. And there was a guy there who tinkers with electronics, but he wasn't really knowledgeable. And he had apparently thought he was going to try and fix this thing and gave up on it fairly quickly. And I looked inside, and there were a couple of things that looked out of whack. I think there was a board that appeared to be missing. I think we may have found that, putting it back inside. But this is a model 6002A Hewlett-Packard DC power supply. This is a 0 to 50 volt power supply that is capable of providing 0 to 10 amps of current, 200 watts power dissipation. So this is a bit of a different animal than that last one. For one thing, it goes all the way up to 50 volts, but the bigger thing is that it's able to provide higher current. And not only that, but we've got some other this judging from the amount of electronics that's in this thing, I would say that this is designed to be a very accurate, well-regulated power supply. It also appears to have built-in self-protection. I see over voltage and over range LEDs. So this might be something worth trying to repair. I don't know yet. So since it's pretty much already in pieces, why don't we take a peek inside this behemoth. And it appears this came from Sprague Electric Company. So before we look inside, let's just take a look at the back, and we can see we got a lot more going on here than your typical power supply. We've got, well, for one thing, we've got this port, HP-1B. Almost seems like that might be a port for a printer, maybe an old printer. Maybe this was designed to be able to output data directly to a printer. It's got an address switch. Don't know much about that. We've got some switches here that say local, CV, and CC. I guess that's constant voltage or constant current. It's a fuse here. Oh, okay, so this is your... oh, this is kind of a neat little feature here. Check this out. So if you want to change the fuse, you have to slide this plastic piece down, and the only way you can slide this down is to remove the power cord. So see? It's impossible for somebody to touch this fuse with the power cord plugged in. And you can't plug the power cord back in unless you've got this covering the fuse. That's kind of neat. I am simply amused. Alright, let's see if I can remember how the hell this thing comes apart. This bottom cover, I think, is not on. Yeah, there's something just rolling around in there randomly. This bottom cover doesn't even look like it's on correctly. Yeah, so like this looks like this should be over this lip, and this screw would go into here. So it's almost like it's off of its track or something. There's no screw here. So does this whole thing just push out the front? There we go. All right, yeah. So here's that board. Just kind of stuck it in there loosely for safekeeping. Look at the size of these cans. Big filter caps, huge. Big power transformer in here. So what we figured out when I was looking at it, when I first saw it, this is how I saw it. And I said, well, it looks like there's a whole board missing. And he says, oh, it's around here somewhere. And then he found this board. So it appears there's a board right here that's vertical. And it plugs into this plug here on this board. Oh, well, that's not good. See, that's one of the things that's floating around in there. That could be a disaster. And then we've got this plug plugs onto these pins, and looks like there's a pin broken off right there. And then we got this little itty bitty plug appears to plug in right here. So then the question is, what went here? Now that might have been maybe another daughter board that went on here, or a little auxiliary board that was an option, because I actually don't see any indication of scrape marks on here to indicate that anything was attached to that. So that's actually a good sign. Maybe this isn't missing as much as I thought. You know, it would probably be pretty foolhardy for me to just slap this board in here and try and fire this up. But I'm just the fool to try it. Oh, okay. So they've got a plastic pin in that hole to block out that pin on the connector. And by doing that and having this pin omitted on purpose, I thought it was broken off, but it was intentionally cut off. And what that does is that creates a interlock situation where this can only go on the one way. So you can't accidentally rotate this around and plug it onto there incorrectly. That's good. All right. All right. In the process of putting this board back in, I dropped a screw that necessitated taking the other cover off. So I was able to figure out how to get that other cover off. I only put one screw in. I looked at all of these screws, even though this is a two-sided PC board. This is the only screw that actually not only does the job of physically mounting the board, but actually is a ground. So it might be absolutely necessary to have that screw in for the circuit to operate correctly. I don't know. But as long as we've got the covers off, before we let the smoke genie out, let's take a look at this thing and see what we can see. Because, boy, when I opened this side up, I saw this. And I was like, oh, wow, look at that. So, what's kind of cool here, I'll get to that in a moment. But what's kind of cool here is this board right here. This board right here has a lot of integrated circuits on it. And not only does it have a lot of integrated circuits, but it looks like this has actual gold traces, like computers back in the day, and some modern computers too. Look at that nasty sucker. Yeah. Arachnophobia. That's the fear of spiders. Anyways, which I would be afraid of that guy if he was crawling around in here and looking at me. But he was pretty crispy. So anyways, kind of neat. So we've got some logic going on here. I'm not sure exactly what. We've got a fancy schmancy looking integrated circuit right here. That is an 1820-1856. A lot of RCA and Motorola chips in here. Also got some HP, genuine HP chips. We've got some good quality electronics in here. We got everybody in here, all the big guys. We got Texas Instruments, Motorola, Hewlett-Packard, RCA, and then over here we got this little fella is a Malaysia. It's a TI. It's a TI, but it's made in Malaysia. This is a TI made in El Salvador. Interesting. Did not know Texas Instruments had such a presence overseas as far as plants go. All right. So I got a feeling that this all has to do with this input-output of data. I'm not even convinced that this necessarily is integral to the operation of the power supply as just a plain brute power supply, regulated power supply. Boy, I bet you those caps could surely store a hell of a wallop. Those are some big suckers there. I can't quite see the rating on them. They are 100 volt DC. Can't see how many microfarads they are. Got to be pretty good sized. They are Powerlytic brand capacitors. They say 7800-100 DC. So I wonder if that's 7800 microfarad at 100 volts DC. So 7800 microfarad, that's pretty decent. That'll take care of your ripple. Okay, so I've got this front faceplate pushed back into position, so I think should be okay as far as not having to worry about it shorting anything out. It almost appears like this line switch stays behind, and you can see it's missing the part that screws on here. So somebody had taken this off effort to take this front faceplate out. Anyways, so this says line, so I believe this installing the plug should not energize any circuits in this thing. Alright, plug seems to be fully seated. I'm betting this thing's going to be dead as a doornail, but I am going to get us a better view just in case. Ready? Oh, that did not sound happy at all. Oh, this is almost like a linear control. It just, oh no, it's a multi-turn, multi-revolution potentiometer, so it's capable of being able to rotate 360 degrees multiple times. Let's see, like 10 times. All right, so let's turn this all the way down. To the left, I'm going to assume is lowest setting. And the current also appears to be the same type of control. Let's see what happens. That just sounds like a lot of current being drawn through that transformer. I'm guessing there's a short somewhere that's causing all that to happen. Yeah, this is a sick puppy. I don't even know if this would be worth doing anything with. You know, and the problem with something like this, if I want to sell it like on eBay, is it weighs a ton. Hey guys, it's the next morning, and last night before going to bed, I poked around on the internet and found some really cool things about this power supply. First thing I did was I went on eBay and looked at sold auctions for this power supply because I was curious what the value was. And the prices are all over the place. I mean, the most expensive one sold, recently sold for $275, but that was with free shipping, and this is pretty heavy. So, I mean, it's probably ended up being like $40 to ship this. Then another one sold for $165, with $35 shipping. So, you know, probably around $150, I would say, for a good working one. But then there's like some that were untested, so the people basically probably got them somehow and didn't even know exactly how to properly test it, had no idea. You know, maybe it powers on, maybe they have no idea whether or not it's working. And some of those sold for, you know, $60 or $70. And then there was even one that sold for $10.50, and then it had $55 shipping. So that's, again, you know, $50 or $60, maybe in as-is condition, unknown. And some of them are HP Allegiant. So I'm thinking that maybe they're still making or made this power supply for a while, and that some of them may have actually been badged Allegiant, which would indicate that they were quite a bit newer. Although I think maybe, see now I'm looking at a listing right now. Maybe people are just putting Allegiant in as a keyword so people will find it. So the relationship between HP and Allegiant, which Allegiant is, you know, a company that a lot of people respect as far as the quality of their test equipment, meters and such. So I found an old copy online of what they call HP Journal, which apparently was a publication that was put out by HP for, like, you know, their own purposes. People, you know, like a kind of like a magazine within the company. A lot of companies did that back in the day. I don't know if that's so prevalent anymore because, quite frankly, companies don't want to pay money for that kind of stuff. But it's really cool because there's an article in there about the team that designed this power supply. And it's neat because it actually shows a photograph of each engineer, and then it has a little bio, and, you know, it talks about his hobbies and interests and where he lives now, and kind of neat. Apparently this was designed by the team in New Jersey at HP as opposed to the West Coast team. And then it talks about the power supply, the theory of operation. So there are some schematics that are like really basic schematics that don't show everything. You can still find a service manual online on a CD-ROM for like $10, and that is apparently the complete service manual, which would also have probably all the alignment information and everything on there also, and troubleshooting and stuff like that. But what was kind of cool about that theory of operation was it kind of explained the way that they designed this and why they did it the way they did it. So the main feature about this power supply is that it has this wide range of power that it's able to supply, the 0 to 50 volts up to 10 amps, but it also is able to change voltage output and current limitation very quickly. And the reason for that, the reason why they wanted to be able to do that is because that port on the back is actually it's an HP interface that allowed this to be controlled by a computer or a controller of some type. So the idea would be that if you were using this in a testing environment and you wanted this power supply to turn on and turn off and maybe turn on at a different voltage or change voltage output and go from 5 volts to 48 volts and then cycle back, you could basically have the computer or the controller, the outboard controller, make it do all of those things. So it's a programmable, I guess, would be one way of saying it, power supply. But it also, a standard power supply, if it's got 50 volts of output and you suddenly turn it down to 5 volts, it's not going to go from 50 to 5 volts that quickly, because you've got these big filter caps in there and that have to drain down power. There's going to be a lag time there, whereas this power supply, because of its unique design, is able to do that, change voltage from high to low rather quickly. And also it monitors the output very quickly. So it sees changes in load demand quickly and can react to that quickly. That's why we got all this electronics in here. We've got so much stuff going on in here, more than just a simple brute force power supply with some simple regulation. That being said, the current problem with it seems pretty bad. That hum is kind of scary. I think I see a blown fuse running on the top here, so for giggles I might just check that fuse and see if it's blown, change it out and just see what happens. But then I'm not going to get too much further into this. If I decide to move forward with the repair of this thing, it's going to have to be a dedicated series, I can tell, just because this is quite the unique animal as far as intricacy of design. So anyways, this fuse right here looks blown. Alright guys, so there are two 6-amp fuses right here side by side that are common. They're tied to each other on this side, and then each one feeds one of these two wires. These two wires go into this wiring harness that goes around to this board on the side here that's got a large filter cap and a big regulating big TO3 style transistor on it that I can see in some other stuff. So I have no reason to believe that just putting this fuse in is going to solve anything. I fully expect it to blow right off the bat. But just for the heck of it, I did check resistance from this point and this point to ground. And even with a new fuse in, I'm getting identical resistance readings, which is, oddly enough, infinite resistance to ground on both of these. So I don't believe we're dealing with a dead short that's immediately after the fuse. It's got to be something down the chain that's causing that fuse to blow, or caused that fuse to blow. What would be really nice would be if that blown fuse was causing some kind of an imbalance in this unusual circuit that's in this thing, and that was what was causing the humming. But I don't think that's going to be it. Let's just see what happens. So I don't think I was getting any meter action before, and now I am, which is interesting. And I'm getting, am I crazy, or was this mode light not working before? So this is the volts available. So as soon as I go above a certain point, it goes to this over range. All right, so the next thing I'm going to do real quick before I stop playing with this thing today is I'm going to see whether or not there's any voltage present at the terminals here. In other words, is it possible this thing is working, but it's actually the meters aren't working? Yeah, I don't like the hum, but... All right, so we're going to look at DC voltage. There's a plus, a minus, and a ground, and the reason why is because this is a power supply that is capable of providing either positive or negative DC voltage. Yeah, nothing coming out of there. That's weird how that sound changed. Maybe that isn't the transformer at all making that noise. Well, that's what I get for assuming. There is a large cooling fan here, tucked in here, blows air across a big heat sink underneath here for the semiconductors. And I tried rotating it and the blade was stuck, and then as I tried rotating it more, I noticed that it was kind of cocked, and it appears to now have broken completely off the shaft of the motor. So there was something wrong with that. I don't know what. And unfortunately, the way this thing's put together, there's no easy way to get that fan out that I can see. But right now, the way it's positioned almost makes me think that I could maybe power this up. And I mean, obviously not a good idea to run it without the cooling fan, but I'm not putting it under any load, making it work very hard. So yeah, it's definitely that fan. That's where all that noise is coming from. Well, all right. We're done playing with this for now.